Now we're going to keep looking at linear regression. Okay, so you're going to need a calculator for this. If you do not have a calculator, just make sure you write down the steps so that you're able to use one when you do get one again. Scatter plots. Scatter plots are a way to organize real-world data. They allow us to look at and analyze the relationship between two variables. Correlation is the relationship between two quantities such that when one changes, the other does too. There are three types of correlation. You can have a negative correlation, zero or no correlation, or positive correlation. I think more often you'll probably hear this called no correlation instead of zero. But a negative correlation basically means you have a negative slope. You're going downhill. Positive means you have a positive slope. And then no correlation means it's not really a line at all. It's kind of all over the place. All right? And then you can even more so clarify whether it's high or low, and then a lot of times this might be strong or weak. Right? So this is a strong positive correlation because it's definitely going uphill to be positive, and it's pretty close. You could definitely see a line. Okay, this would be a lower positive or a weaker positive correlation because it's still going uphill from left to right, but they're a little more scattered and they're not as much of a straight line. All right, and same thing, you got high negative and low negative. Again, you might have strong or weak. So this is a strong negative because it's closer to a line going downhill. This one's a weak negative because it's a little more scattered but still going downhill. And then no correlation is just scattered. So what type of correlation do these graphs have? I would say this one on the left is definitely positive. I'm going uphill, and it's pretty strong. So I would say that this is a strong positive. And this one on the right is definitely negative, and I would say it's probably a little weaker just because it's not as strong as the one on the left. So I would say this one is a weak or even a low negative. Okay, linear regression. You can find the equation to model data in a scatter plot and use it to predict future values. This line is often called the line of best fit or a trend line. So we're taking the data that we have and we're going to create a line that fits it so that we can predict in the future or in between if we don't have the exact point. Right? The table shows the average monthly outside temperature and the corresponding average monthly heating cost for a two-story home during the fall and winter of 2000. I want to make a scatter plot and find the linear regression equation. So here are steps for making the scatter plot. First, we go to Stat, go to the first one, Edit, and then we've got L1, L2, L3, and so on. We're going to put our X values, our independent values in L1, and our Y values, our dependent values, in L2. Then we're going to go to second Y equals, turn our plot on, and then we're going to go to our graph, and we're going to zoom Stat to get a nice pretty picture of our graph. All right, so I'm going to pull up the calculator and scooch it over a little bit. That first one is a 58. So Stat, Edit, and I got 58, 47, 34, 28, 38, maybe, and 44. Okay, and I just typed those on my keyboard to save some time. And then in the other column, we're going to have the price to heat the house up. So you got 51, 73, 96, 145, 102, and 85. Alright, now I'm going to make sure my stat plot's on. So I'm going to go to second Y equals. And right now the off is what's highlighted. So it's cursor's on, press enter. And then I want to look at my graph. But if I look at my graph at first, I don't see anything. It's not the right window. So I'm going to go to zoom and go all the way down to number 9 for zoom stat. And it's going to automatically adjust the window for me so that I see all of my points. All right, and I'm looking at this and I can tell that this is a strong negative correlation because they're pretty close to making a line and it's going downhill. All right, so now I'm going to use that same information to find my linear regression equation. All right, and then I'm going to use that to predict the cost of heating if the temperature is 48 and what's the likely temperature outside if the cost is 85. So two different questions we've got here. Keep in mind, 48 is close to 47, right? But it's not on or not in my table exactly. So that's why we're using this line of best fit. So I'm going to go back to my calculator somewhere. All right, to find your regression equation, I'm going to go to Stat, go over to Calc, and I'm going to go down to LinReg for linear regression. Okay, if you've got a TI-84, you got to scroll down to calculate, and 83, we're just going to press enter again. So I've got this equation, negative 2.8 plus 209.1. All right, so if I round it, I've got negative 2.8x plus 209.1. Okay, I'm going to go to y equals to put it in. Now you can just type in your rounded equation, but you want to try to be as exact as you can. So we're going to paste it. So to paste, I'm going to go to VARs, scroll down to statistics, over to EQ for equation, and I want the first one, the regression equation. So I'm just going to paste it in there. It's going to do it for me, and it's not rounded like it would be if I typed it in myself. Now I'm going to look at my graph, just to double check to make sure this is a good fit for my data. And I would even say that this is a very good fit. And notice how my points is kind of like in the middle of my points, so this would be a strong fit for my data. All right, so I want to predict the cost of heating if the temperature outside is 48 degrees. So that's 48 degrees, that's an x value, right? That's my independent variable. So if I know my independent variable, I can just look at my table. So if I go second graph, I've got my table. Now it starts at 0, so I can scroll down for a while and find 48. Or I can make my life a little easier and change my table set. I'm going to go second window to get to this little table set, TBL set, and then I can choose where I want my table to start. So right now it's starting at 0, so why not make it start at 48? And then I'm just going to go back to my table, and there's 48 right on top for me. So 48 degrees is 73.656 to pay for it, so you could just say $73.66. So for this one, we got $73.66. Right, then what is the likely temperature outside if the cost is $85? This 85 is a Y value. So now I want to look to see when Y is $85. Well, if I look at the table, I don't have any that are pretty numbers anymore. Right? They're all decimals, they're all rounded. So it's going to be hard to find 85. Like for example, there's 87, 84, 82. We skipped right over 85. So if I know the Y value, I'm going to go to Y2 and put that Y value in Y2. So I'm going to put 85 in Y2. And then I'm going to look at my graph. So now I'm going to have a horizontal line going right through the middle. I want to know when my line of best fit is 85, so I want to know the intersection of those two lines. So to find the intersection, we'll let the calculator do it for us. I'm going to say second trace, scroll down to intersect, and then it's going to ask me first curve, second curve, and to guess. And all you do is say enter, enter, enter. So my intersection is at 43.98 and 85. So you got 43.98, 85 is the intersection. So the degrees is 43.98 or 44. So at 44 degrees is what it's going to be for the price to be 85. Now you could also do this by hand. You could do both of these by hand. We could take 48 degrees and plug it in for x in my equation and solve, and you're going to get something close to 73.66, but maybe not exact because this is a rounded equation. And same way, I could take 85, plug it in for my y, and again get something close, but maybe not exact, it's 43.98.